Hello everyone, this is Jashwant. In this video, I'll walk you through our big data project based on New York City motor vehicle collision dataset. I built an end-to-end pipeline using Databricks serverless for processing, MongoDB Atlas for our distribution NoSQL data platform, and Python for data cleaning, aggregation, and visualization. As you can see, this is my GitHub repository for the project of the New York collisions. And in here we can find the readme file where we have the total project overview, systematic architecture, dataset details, and raw layer, silver layer, and everything regarding this dataset. So the dataset comes with a New York City open data and contains over 1 million motor vehicle collision records with more than 20 attributes. We can see in the my MongoDB where the document is around 100K. So the dataset it also includes date, time, location, injuries, and facilities. Because of the data volume and semi-structured JSON format, this data is well suited for distributed NoSQL system rather than a traditional relational database. And after this, our architecture overview. This diagram shows our overall architecture. Data is ingested from REST API into Databricks serverless, processed using Python, and stored in MongoDB Atlas using a layered approach like raw, silver, and gold. So the very initially it starts at New York City Open Data API collision where we are like gathering our raw data and we are implementing it into a Databricks. After that we are making into a raw layer, then into a silver layer using Python, pandas, cleaning, and all that thing. After that, we will do a validating the schema using Pythonic. After that, it will we can move.
Hi, this is Madhu. Now I will explain the raw layer ingestion. You can check here in the raw layer we ingest the data directly from the New York City Open Data REST API without storing the files locally. The raw JSON data is inserted into the MongoDB Atlas using the batch inserts to ensure the reliability and scalability. As shown here, the raw collection contains around the 100,000 documents confirming the successful data ingestion. Next, I will show you the silver data. You can check here. In this layer, we handle the missing values, normalize the text fields, standardize the data and timestamp formats, remove the duplicate collision records, and fix the data types for the Mongo compatibility. Before storing the cleaning data, we validated the schema using Pydantic to ensure the consistency and correctness. The cleaned and validated data is stored in the this MV collision silver collection. Now we can move to the gold layer, which contains analytics ready datasets created from the cleaned silver data. From this gold layer, we generate the visualizations, better understand accident patterns and trends. In this gold layer, we create aggregated views such as accidents by Baru, injury and fatality summaries, and daily accidents trends. These aggregated results stored as a separate gold collections in MongoDB and are optimized for the fast querying visualization. Now let's look at the visualizations created using the gold layer data. This first bar chart shows the total number of motor vehicles accident by Baru. It highlights the Brooklyn and Queens having the highest accidents counts, helping the identifying high risk Barus. In this visualization, too, next the stacked bar chart compares the number of person injured and killed access the Barus. It shows the injuries are much higher than fatalities, indicating the accident severity by location. In this visualization 3 like Then this line chart shows the daily trend of motor vehicle accident over time. It helps to identify the patterns, fluctuations in the accident frequency. Finally, yeah, in the pie chart shows the overall accident severity distribution. Most accidents results is no injury with fatal cases for a very small percentage. Together, these visualizations provide the clear insights into the accident severity and trends.
Hi, my name is Hemant. To conclude, this project demonstrates an end-to-end big data pipeline using real-world New York City motor vehicle collision data. We process the data using Databricks serverless and then stored it into MongoDB Atlas with a raw silver and gold layer architecture. The gold layer enabled fast analytics and visualizations, while silver layer ensured data quality. Overall, this project provided hands-on experience in building scalable big data systems and deriving meaningful insights. Thank you.